if we go back and look at that one again, do you see where the asymptote is? Sorry, I said horizontal, but I meant vertical we're going to look at first. Do you see where the vertical asymptote is? At 0, it's like on the y-axis, right? But it's where the y equals x is equal to 0. And that's what's going to happen with every reciprocal, because that's where you have that point that was undefined. So the first thing, value is given. So the y value here is going to be negative 1 over 2, negative 1 over 1, negative 1 over 0.5, which is equal to 2, negative 1 over 0.25, which is negative 4, 1 over 0, which is undefined. I'll just put U and D for undefined. 1 over 0.25, which is 2, and then we've got 4, 1, and 1/2. Oh, sorry. Yeah, you're right. 4 and 2. I was thinking ahead and wrote them backwards. I did it again, did I? No, I'm good now. Phew, okay, first day back after March break. It's kind of tough. So we have these points, and then plot them on the graph, and the graph ends up looking like this. That's kind of faint, but hopefully you can see it all right. This green line is just y equals x. And these two curved lines, that's y equals 1 over x. One of them is the reciprocal of the other. Reciprocal means flip it over. So the green one, like I said, is y equals x, and the blue one is y equals 1 over x. Those two are reciprocals. So then it's going to ask us, how do you draw the reciprocal of a graph? The first step is going to be to draw in the vertical asymptotes. So that's going to be here. Usually, we're going to draw it as a dotted line because it's not actually part of the graph. It just defines where the graph is. So a dotted line where the original function is equal to 0. And then we're going to look for non-permissible values. And if you think about what a reciprocal is, you take a number and you flip it over. What number is the same when you flip it over? So if we start with 2, we flip that over and we get 1 over 2. That's not the same, right? 2 goes to 1 over 2. But what number, if you did that, would not change? 1. 1, when you flip it over, it's 1 over 1. It's still 1. So that's the next step, is the invariant points. Draw invariant points at 1 and negative 1. So let's take that. Here we have 1 and negative 1. Those are the 2 points where the original function, the y value of it, is equal to 1. Because when you take the reciprocal of those, they don't change. And then basically the third step is if the function was positive, then the reciprocal is going to be positive. If the function was negative, then the reciprocal is going to be negative. So it's these two things and their opposites. Where the function is positive, the reciprocal is positive. So basically everything that started out in the positive, it's going to stay positive. And if it started out negative, it's going to stay negative. And then where the function is increasing, so that means going up from left to right, the reciprocal is actually going to be going down from left to right. So function twice. Oh, sorry. That should say the reciprocal will be decreasing. So basically it's going to look like this. It's going to come down there and go through the invariant point, and here and through the invariant point. The mapping rule for graphing a reciprocal. X stays the same, right? But you take the reciprocal of y. So that's another way, without going through the steps, that you could graph a reciprocal, is just find the reciprocal of every y value. So if we look at a point like, let's see, a point on the original function like this one here, that would be at 2, 2. If we wanted to find the new point, it would be at 2 and 1/2, 1 over 2, which is about there. Maybe a little lower than how I actually drew it. But that's another way to do it, is just look at a mapping rule. This is the reciprocal of a quadratic function. So what I was saying, well, this is giving me a hard time. Okay, I'm going to forget about that. Let's just look at this. We'll try again. One of these graphs, the green one, is y equals x squared minus 4, and then the other one is this, y equals 1 over x squared minus 4. What I want you to notice is that those rules that we had for the other one still apply. If you look at where the vertical asymptotes are, they're at the zeros of the original function. So when you're doing a reciprocal, that's what you're going to find. We look at where the green one, the original function, crosses the x-axis, that's where you find the vertical asymptotes. If you're looking for invariant points, they're at 1 and -1. So actually, here at 1 and down here at -1. So there are 4 for this one, because it's where the original function was equal to 1, right here, and where the original function was equal to -1. And then on the outer parts, that's where the function was positive, so these parts stay positive, and the inside part was negative, so it stays negative. And you'll see the function to the far left is decreasing, so the reciprocal is increasing. It continues to decrease after that asymptote, but then increase. So you see the opposite with the reciprocal, it increases, then decreases, and so on. So it follows those same rules that we had for the linear one. Those are the rules for all reciprocal functions. With this one, I quickly want to draw the reciprocal. This gives you an original function, and it tells you this is f of x, and asks you to graph y equals 1 over f of x. You could be given a question on an exam. You're not going to be asked to draw a whole function like that, but you could be asked something like, when you take the reciprocal, how many invariant points will this have? Or you could be asked, how many vertical asymptotes does it have? Or where does this particular point transform to? Those kind of questions they could ask you, and that's why you need to be able to do this. You're obviously not going to have to graph the whole thing in a multiple choice question, but they could ask you elements of it. So when we go to graph it, the first thing we need to look at is the vertical asymptotes. How many vertical asymptotes will it have?
Does that count as 2 or just 1?
So if I draw those 3 in, they're going to be at every x-intercept. So there, and here, and here. What about invariant points? It will have 6 invariant points. So like I said, everywhere where the original function is equal to 1, so it's here, 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 and here, and then where it's equal to -1, which would be there and there. 6 invariant points. So that could be a question for sure on the departmental. give you a graph like this, ask you if you take the reciprocal of it, how many invariant points can you have? You can't really use your calculator to do that unless you're going to go through all the work of trying to figure out what the original function, what the equation of the original function was. I think it's just easier to know kind of how this stuff works. So then I can actually draw in the graph, and I'm going to do it, like I said, everywhere where it's positive, it's going to be positive. Everywhere where the original is negative, it's going to stay negative. And it needs to do the opposite in terms of increasing or decreasing. So if we look at this first section over here, the function is decreasing. The reciprocal needs to be increasing, and it needs to go through that invariant point. So it's going to come kind of like this, and then down there. It's a little bit hard to draw on here. If I look at the next section, it's going to increase and then decrease. So it's going to be here, across there, oops, so it kind of slipped, and down through there. The next section is positive, so something like that, and then another positive section like that.